teacher.
All right. We're going to go over division. We're going to do two methods, traditional, which ones most of you are familiar with. Then we're going to go over this new method. This one's going to be a little tricky, pole and flag. You probably haven't seen this before. Then I'm going to discuss the three types of answers you can get. Then I'll discuss when to stop. When you have something that's in a decimal, when do you stop calculating? How many decimal places do you take to? And then there's your homework, due Saturday. All right, a basic division problem. It starts out with this 2 represents your divisor. It's being divided into this number, which is your dividend. Okay, and your answer is your quotient. So if you ever see a word problem where it says, what's the quotient of a couple numbers, they're telling you, divide. Okay, everybody clear on that?
Yeah.
Mm-hmm.
All right, let's get
into it.
right into it, yeah. I'm going to start out with a problem here. Okay. We'll put the decimal point there. Whenever you have a decimal point in your dividend, you just project it directly up into your quotient. So this is directly in line. All right, we're going to use the traditional method this way. This is probably the way most of you were taught to divide. We take the 2. Does the 2 go into 3?
Yes. One time.
Yes, one time. All right, so we'll put a 1 here above the 3. 2 times 1 is 2. We're going to subtract that away. 3 minus 2 is 1. We're going to make a quick check here. This is our remainder. Is our remainder less than our divisor?
Yes.
Yeah.
If it is, that means this number is good. If the remainder is equal to or greater than our divisor, then this number isn't high enough. You got to go increase it by 1.
Oh, I never knew that.
Wait,
So
what
that's a good
happened?
check.
What'd you say? Sorry.
Nothing happened.
Oh. No, what did you just say?
What did I just say?
Yes.
What did I just say?
If it's higher than the 2, we have to add 1 to it?
See this here?
Yeah.
This number always has to be less than this number.
Okay. Oh, yeah,
If
that
it's
makes
equal
sense.
to or higher, this number here in the quotient isn't large enough. Okay?
Yeah, no, you're right about that.
Thank you. I'm glad.
I just have to let you know you're right.
Thank you for telling me. That's why they pay me the little bucks, because I'm right all the time. All right, so this is less than this. That number's good. We bring down the 6. Now we ask ourselves, how many times does 2 go into 16? 8. So now, 8 times 2 is 16. We subtract this away, it goes to 0. All right, so we don't have any remainder on that. That went in perfectly. Now, 0 is less than 2. 8 is good. That's a good number, right? So now we bring down the 1. Here's where a lot of people get confused.
Yeah.
2 does not go into 1. All right? Anytime you bring down a number here, you have to put up a value in your quotient. So even though we brought down this 1 and 2 doesn't go into 1 because 1 is less than 2, we have to put a 0 here as a placeholder. Then we bring down the 5. Okay? Does 2 go into 15? Yes.
7.
7 times. So 7, and then we're going to say 7 times 2 is 14, subtract away, we get a 1. Okay? Now,
Wait, does the 1 go up? Is it 0.1 now?
no, it's not 0.1.
Oh. That's the remainder.
1 is the remainder. Now let's go into what the different types of answers we could have. So let's call this types of answers.
You put 0.5? No. Yeah, you could have a 0.
All right, we're going to have 3. One way is, we could look at this number, right, and it ends over here at this decimal point. We got a remainder of 1, so we could call the one answer 1807 with a 1 remainder.
Okay.
That's one way we could do it, right? And that's an accurate answer, perfectly acceptable. Another type of answer we could have is we could say it's 1807 and 1/2. And the way we get that, because that's an exact answer, we take the remainder and put it over our divisor. Our divisor becomes our denominator, our remainder becomes our numerator. That is also an acceptable answer.
I saw a fracture, my anxiety just went.
All right, realize it's not going to hurt you.
So say instead of 2 it was a 6 and the bottom number was like a 5.
Well, it could
Maybe 5
never,
over 6.
if this was a 6 and this would be 5, yeah, 5 over 6. If, say, it were 10 over 12, then you've got to reduce it over there to simplest form.
Yeah.
All right, same thing, same rule of fractions applies to that part. All right, so we got two types of answers here. We got one with a remainder, one with a quotient and a fraction, right? What's the other answer?
Decimal.
Well, we could figure out this as a decimal, right? So we could add a 0 here, right? Or a series of zeros here. Does that change that answer or that value? No, not whatsoever. Now I can bring down another 0, and I've got 10 here, and 2 goes into 10 how many times? 5. And this is 10. I subtract away, I get 0.
Yeah.
So now, another way of answering this is it's 1807.5.
Which is the same as 18.
It's the same thing as 18 and a half, and it's the same thing as 18 and with a 1 remainder. All of those are the same value. Now let's understand something. If this one terminated, this decimal, if this were repeating, if you had a repeating decimal, this is more accurate than a repeating decimal. Because in a repeating decimal, we're going to use bar notation. Let me give you an example. I'll go over it. Let me do an easy one here.
Oh my gosh.
I'll change this over. Relax, relax, we'll get there.
I'm not excited about this.
All right, here. I'm not going to do all the multiplication because I know this one repeats, right? 9 doesn't go into 1. 9 goes into 10 how many times?
1.
Subtract away 1, we get 1. What's going to happen?
You're gonna lose
Gonna
your-
keep-
1 is going to, yeah. 1's going to repeat, right? Because I bring down a 0, I got 10 again. 9 goes into 10 once. Subtract away 9, I'm going to get 1 again. This is going to happen for infinity. So in math, there's something called bar notation.
Oh, yeah.
And what bar notation says is this number repeats for infinity. So if we wanted to write this answer, what we would write it as 0.1 with the bar notation. That means this 1 repeats. Goes on forever.
Brings back memories.
Okay? Now, it doesn't have to be just over 1 digit. Say it repeated like this. Right? You could write that as 0.12 repeating. That's saying the 1 and the 2 repeat. It could be 357. It doesn't matter. Okay? All right, so now let's get into, we talked about the 3 types of answers. We got them right there. The one is a remainder, one's with a fraction, and one's with a decimal. How do we know when to stop the decimal? Nobody knows?
After
When
3,
it's in the lowest form.
When it's in the lowest form.
or you go up to 3. After 3 decimal point, you stop.
What happens if it goes out to 5 and terminates?
I know the rules are 3, I don't know about 5.
You know the rules are 3, not 5. Let's go, when to stop a decimal. We're going to go with 2 ways. First way, I think this is what you were saying. It's predetermined. All right. What it's saying is they're going to tell you, carry this out to 2 decimal places. Carry it out to 1 decimal place. That's as far as you have to go. Okay? So, if they say only take it out to 2, that's all you have to take it out. Only take it out to 1. Now remember, as we add more and more decimal places, the number's getting smaller and smaller, right? So if we were calculating tablets, could we take 1/10,000th of a tablet? It's ridiculous. So you're probably only going to, for a tablet, you're going to round off to maybe 1 decimal place. Okay? All right, so that's one. It's predetermined. They're going to tell you the number of decimal places. The second method to determine if you're not told is it either terminates or repeats. All right, so now in that previous one where we had 9 into 1, it was 0.111. As soon as it starts to repeat, you can stop right there. If it zeroes out like we did on most of them, that's when you can stop as well. Okay, everybody clear on that? Make sense? All right, so when are we going to stop? If it's predetermined, we're only going to take it to some number of decimal places, which we've already been told, or it terminates or repeats. Now, since the problems I give you are already predetermined, they're usually going to terminate before at around 3 or less. So if you take something out to 5, chances are you're making a mistake. Okay? Unless it's an extra credit question, then it may take it out a few more. But for the normal problems, if it goes more than 3, you might be doing something wrong. All All right, everybody good on this? Is that still running? Okay. All right, I'm gonna take this off because I want to do some more problems. Everybody good? Everybody got this in their notes?
Yeah.
All right. All right, let's take this problem right here. Actually, I want to start out with this one. All right, we're going to start out with this 7 goes into 756. Now, if I wanted to, I could put my decimal point here because it goes in and project it right to the top here into the quotient. All right, first thing, how many times does 7 go into 7? Once. Okay, so 7 times 1 is 7, subtract that out, 0. All right, that terminated out. We bring down the 5. Oh, wait a minute, before I do that, I do my check. Is 0 less than 7?
Yes.
Yes, so that number's good. All right, now, does 7 go into 5? I brought down the 5.
No.
No. All right, I brought something down, right?
Yeah.
Something has to go up here as well, so I put a 0 over the 5. Now I bring down my next number, 6. Does 7 go into 56?
Yes.
8 times. This is 56. Subtract it, we get 0. It's terminated, I don't have to take it any further.
Calculate
All right. Now, if we wanted to check this, couldn't we multiply this times this and get this answer?
Yes.
Because if you did it right, that should be correct. So 7 times 8 is 56, 6, 5, 7 times 0 is 0, plus 5 is 5, 7 times 1 is 7, 756. Worked out. Did that one right. Make sense?
Yeah.
All right, let's try the next one. Oh, right here. Got a little ahead of myself. All right, does 26 go into 3?
No.
No. All right, so we go to the next number. Does 26 go into 36?
Yes.
How many times?
Once.
All right, so I put the 1 over the 6. Now, because it didn't go into 3, I could put a 0 here, I could put an X here, I could just leave it blank. Whichever you prefer. For alignment, I just use mine blank, but I've seen students either put zeros or X's here. Doesn't matter. Whatever works for you. All right, so I put a 1 over the 6. 26 times 1 is 26. I'm going to subtract that away from 36. I'm going to get somewhere in the vicinity of 10. I'm going to do my quick check. Is 10 less than 26?
Yes.
Yes? That's a good number. All right, now, I got 10 here. I bring down the 1. Does 26 go into 101?
Yes.
How many times?
4.
4. So I put the 4 over the 1. 6 times 4 is 24.
Wait, I thought you had to put a 0 because it didn't go into 10.
10 is the remainder.
Oh, all right. Okay.
They just brought the other
Brought
one.
down the 1, so this goes above.
So it's 101 now.
Yeah, all right, so 6 times 2 is 24, 8, and this is 10. Is that right? Wait a minute, what's the problem here?
I raised it.
No.
Yeah, a little too high, right? Because 101 is larger, so 4 is too high. So let's change it to 3.
4 quarters in the I know, I'm like, so I was like, 4.
18, oh, I forgot to put the 3 here. 3 times 6 is 18, 1, 6, 7, 78, right? Let's subtract that away, what are we going to get? 23.
That's why I was right. I was like, that ain't right.
That was a good mistake, though. That was good for instructional purpose. If you ever do that, that's a good, quick way of checking. All right, now, is 23 less than 26?
Yes.
Well, now the 3 is good, right? All right, so good. Now we bring down the what? The 4. How many times does 26 go into 234?
7.
I don't know.
6?
Not the top.
7?
Sure.
All right, let's go like this. Let's do it this way.
26 times 7, yeah, you gotta figure that out.
I got 182 with 7.
Oh, I think
So
8.
8.
I think 9.
It might be 8. Maybe.
All right, 16, this is 20.
Oh,
No. 9.
you can go one more time.
No.
No, we
No, 8.
Nope.
8.
Oh, that's.
Now another 34 would go over, so it's 8.
Right.
All right, so it's 8 over the 4. We're going to put a decimal point here, right? And we're going to get 208. We're going to subtract that away, and what are we going to get?
30. So shouldn't that have been a 9 then?
Oh, 26
And that's-
is 26, right?
That's one.
No, it should have been 9.
That's,
Oh, we said 9.
no, because that, I think that's supposed to be a one.
What?
No, right here.
Where?
Because it said you cancel the 4 and then you put 2, that should be a 1. Go ahead,
Where am I?
right there, yes. When you put the 4, yes, so you should cancel the 1, the 3 and put 2. So you have,
No.
No.
Remember, you brought down the 1 to make 101.
Yeah,
Now we
78.
go to 4.
That's what I got as a remainder, 23. Then I brought down the 4.
now when you were canceling out, when you put the 200 and, how much again?
What is it?
Go again,
208?
208, yeah.
Oh, let me do it.
No.
18.
So now 26 times 9 is
Yeah, this is 29, so it'd be 54, right? 4,
Yeah.
So what's wrong?
18, 234.
Oh, bingo.
So 9.
So, yeah.
So that terminated.
That doesn't make any sense.
How do you know to put the decimal point?
All right, the decimal is always at the end of the number.
No matter what.
Yeah. Then you just project it up.
So this is a terminated.
This one terminated. When it goes to 0, that's terminated. All right, now we learned a lot on that one. All right, here's one where a lot of students make mistakes.
Okay, so I have a question.
All right.
Is this where we use the calculator?
No.
Oh my God, I don't know.
I'll tell you when you can use your calculator.
Oh my God.
All right. Here. All right. Does 39 go into 3?
No,
So we leave the first space. Go to the second. Does 39 go into 39?
1 time.
We get a 0. Is 0 less than 39?
Yes.
Okay, that number's good. We bring down the 3.
Add a 0.
Wait a minute. Oh, add a 0 where?
I know, that's where the problem is, there, right there.
In the quotient. All right, I thought you meant bring this down to 0. That's all right. You got me. You got me. I was picking daisies on that one. All right, so we bring down we put up the 0. Now we bring down another 39, and it's going to go in once, right?
1, yeah, and it's terminated.
And it terminated. Now, if we multiply 39 times 101, we're going to get 3,939. That works out. So be careful when you bring something down like the 3 here, and 39 doesn't go to 3, you got to put a 0 in the quotient. Remember that. Anytime you bring the number down, you have to put something in the quotient. We got it?
Yeah.
How come you don't have a decimal up there?
Didn't need it.
Why?
Here, makes you happy? You got your decimal.
Because you want to divide it.
It terminated.
It did terminate. All right, let's try this one. Is that still on?
Yes.
The red light's still working?
Yes.
Not that I don't believe you, but.
It is.
Don't make it shut off yourself by doing that. Have to touch a button.
Keep your eyes on Courtney's hands. Who knows what she might do?
I'm gonna throw some.
All right, does 39 go into 4? Does 39 go into 40? Wait, whoa, 36 go into 45. That's how mistakes happen.
Oh, it's 36.
Yes, 1 time.
One time, all right.
It's gonna be 9.
Thank you, Courtney.
You're welcome.
Yes.
Is 9 less than
You're
36?
welcome.
Yes.
Yes, okay, so this is a good number.
This video's gonna be funny.
0. Does 36 go into 90?
Yes.
2 times.
2 times. So put a 2 here. This is going to be what, 72? And this is going to be 18. All right, now, is 18 less than 36?
Yeah.
So 2 is good. All right, so far we're doing pretty good. We bring down this last 0 here, we get 180. Does 36 go into 180?
Yes.
How many times? 5 times. We put a 5 here. 5 times 6 is 30. 0, 3. 5 times 3 is 15. Plus 3 is 18. Subtract it out, it terminates. 125.
Terminated! Don't forget your decimal,
Don't need it.
but you should.
All right.
A lot of these are terminated.
You want one of my repeats?